everyone. I hope you're having a great day. I'm making this video just in case I'm not here, but if I am, I want you to watch it for the solutions to the what's it called? Chapter 7 practice test. So you could skip to those. Just look for when I start to go over that right around here. Look for that number 1 to start seeing solutions to those. If not, we're going to get started here in class to just give you a little heads up about what's on your quest next class, and I'll go over question number 1 on this practice, as well as some tips for how to know when to do which type of sampling distribution. So first, I just want to make sure everyone is aware we do have a quest next class. It's quest because it's only on chapter 7, so we've only had 5 lessons, and so it'll be 50 formal points. I believe it's 15 multiple choice and mix of multiple choice and numeric entry in Canvas. So in order to study, the best way to do it is to look at all the materials we've used in Canvas so far and in AP Classroom if you haven't looked at any of the AP Daily videos. Those are great in addition to the personal progress checks. Today your classwork will be this review sheet where I want you to do number 1 as a warm-up, well, kind of number 1, and then a practice test and sampling for a classwork grade. So first, when I say number 1, I just mean the first FRQ here. So it's 1 through 7. So I want you to give it a try. This one is really scaffolded, so it should be simpler for you to do than the others. So give it a shot, pause the video, and then you can come back to watch as I go over the answers. This one I'll go over them with you. The next few I'll set them up for you, and then you can look at the answer key for the rest of the solutions. Okay, so one of the hardest things about this unit is knowing when to do what. This one, first we'll read the paragraph, Charlotte-Mecklenburg Schools. So we have a random sample, and that's 1 sample so far. And then it looks like, in fact, 70%. So what I'm noticing is that I can see P equals 0.7 and N equals 500. And that's going to be then a 1 proportion problem. So when it says, what is the shape of the sampling distribution of P hat? Well, I don't have a shape on my formula sheet, but these are their 4 sampling distributions right here. We have 1 population, 2 populations for proportions, 1 population, 2 populations for means. So these 4 are, this is Unit 5, Day 2, Unit 5, Day 3, Unit 5, Day 4, and Unit 5, Day 5. So each of these is what we've learned. And then the only thing that's not on here is the shape. So I can add a little note right here. I'll just say approximately normal when n times p is at least 10 and n times 1 minus p is at least 10. And for this one, it's going to be approximately normal when, and there's 2 rules, either the population is normal or your sample size is at least 30 by the central limit theorem. So I think just organizing it onto your formula sheet is a great way to keep it all together. Plus you're able to use that on any assessment for now. And so hopefully that will be helpful. So in this case, I see just 1 p hat. Even in the problem itself, it just has that p hat. So I know I'm using this row of information. We haven't learned standard errors. So right now, I don't want you to cross it off because we definitely need it. Right now, we don't need this column on any of the tests, but we will use that next unit. So I don't want you to cross it off actually. Okay, so I just wrote down the shape a minute ago. What I do is I like to write approximately normal when, and I like to write the rule down. And then I just check it. So we have 500 parents, 0.7. That equals 350. That's at least 10. And then 500 times 0.3 equals 150, and that's at least 10. The mean, right here, there it is, mean. So everything is going to come from this paper. The yellow paper. Mu of p hat equals p, and so that will equal 0.7. The standard deviation, sigma of p hat, it's right there on the formula sheet, square root p, 1 minus p over n, and that is going to be square root 0.7 times 0.3 over 500, which equals 0.0205. Now this is dependent upon that 10% rule or condition. And so we want to check that 500 is less than 10% of all CMS parents. We probably have 5,000 CMS parents at Ardrey-Kell, so that is, oops. So that means capital N should be at least 5,000. It's probably true. Number 4, what's the probability that more than 75% will support the plan? So we want to set up our stuff. We have P of P hat from the 75% of the samples, that's a P hat, is greater than 0.75. We know we have a normal distribution from number 1 with mean 0.7, standard deviation 0.0205. We will draw the normal curve, put 0.7 in the middle. Now 75% would be a little bit more than 2 standard deviations, and we'll calculate the z-score to be sure. So we have our value minus our mean over our standard deviation, which gets us 2.44. And like I said, just to the right there, we will use table A, find 2.44, and we get 0.9927. And then we'll do 1 minus 0.9927 because we're shading to the right and table A is to the left, and we get 0.0073. Number 5, what's the probability to be within 3 percentage points? So we have, what's the probability of that? And my population is 70%. So within 3 would be from 67% to 73%. And we'll do everything almost the same. Draw my normal curve. So I want to label capital N 0.7, standard deviation 0.0205. And then I will calculate z-scores. And I get 1.4 or negative 1.46. And then I'll do it again, but it's the same z-score. Oops. Well, it would be if I wrote it correctly. There we go. So 1.5, 1.5. I'll shade between this time because it says within. So when we do the between ones, remember we'll go to table A and we'll find each one. And so I got 0.9279 for the positive one. Minus, you just do the big one minus the small one, 0.0721. And that gets me 0.8558. That's my answer. All right, number 6, how large a sample will I need to reduce my standard deviation by half? So basically, I can just think about the formula. It's P, 1 minus P over N, but I don't know the N, but I do want it to be 1/2 of P, 1 minus P over 500. So we do a little algebra and figure out that N should be 2,000, 4 times larger. One way that you can figure that out is just thinking about the way the algebra works, having the sample size in the denominator. If I make this a 4, then I square root it, pull it out, like equals 1/2. That's how that works. You could also algebraically solve for it. Remember, if I had 0.0205 as my standard deviation, and I want it to be half of that, then that means I want my standard deviation to be 0.01025. I'll square that, do 0.7 times 0.3 divided by that, and I algebraically can round up to 2,000 because I know mathematically it's supposed to be that. But that is one way, just to set up a little equation and solve. Number 7, how would my answers change if only 200 parents responded? So in number 1, if I recheck that, let's see, with 200 parents and 70%, so 200 times 0.7 equals 140. 200 times 0.3 equals 60. Those are both greater than 10, so it would be still approximately normal, no change there. Number 2, my mean equals P. It has nothing to do with the sample size. No change there. And number 3, to answer that question for the standard deviation, I would do square root P 1 minus P over N. And if my denominator decreases, then this will increase. And I can tell you exactly to what, 0.0324 if you want to do the math. As long as there are at least 2,000 CMS parents, but there would be. So that is all of number 1. I just wanted to do that with you and explain a little more about this formula sheet in case you're getting confused about different distributions. And then what I'm going to do now, I'm going to go through each question and just help you figure out where to look for the information. They get a little bit less scaffolded for each one, and then I'll do the multiple choice. So this one, if you look, you see this is a percent, and this is a percent. So we have P equals 0.6 and another P equals 0.45. And so it looks like we have seniors and juniors that I would want to label. And now they also did that for us right here, which is helpful. So looking at your formula sheet, that is this row now. So everything is there, just these first 2 columns. So we have the shape approximately normal, center is this formula right here, and standard deviation or variability is this formula right there. Number 2, I'll just set up for you, what's the probability that the proportion of juniors who work is higher than the proportion of seniors who work? So I have seniors minus juniors as my distribution as stated right here. I'm not allowed to change that. That's what they told us to do, seniors minus juniors. So if a higher proportion of juniors are working, then when I subtract these proportions, I would get a negative. So just think about that right now. Right now there's a difference of 15% more seniors working. If more juniors worked, then the difference in the sample proportions would be negative from a sample of 25 from each grade level. So that is how you set that up. You have your normal distribution from number 1 that you can do everything with from there. Next one, the scores of the ACT recent year had a normal distribution with mean 20.4, I'm sorry. Standard deviation 5.8. This is one distribution, one population. And you look at number 2, and SRS of 30, and then we have 1 X bar. And so we're using this set of formulas for the third FRQ, and you can do the rest of that. And then the last one, the average amount of time seniors work is 22 hours, standard deviation 7. And then juniors, we have another 19 hours, standard deviation 6. So in this case, we have 2 means, seniors and juniors. And so we're looking at now this last one right here. So we're going to be doing each of these 4, and you just need to know when to do it. Now on this question, there's no guidance at all, no A, B, and C. So this just asks, what's the probability that the average work time of a sample of 36 seniors is higher than the average work time of a sample of 25 juniors? So I'm going to do the mean from a sample of seniors minus the mean from a sample of juniors is positive. So seniors is higher than juniors. That means that seniors minus juniors is a positive number. So once I have that set up, then I know I'm going to be doing mu of x bar s minus x bar j, sigma of x bar s minus x bar j. I'm going to be using all these formulas to do it on this row. I need to describe the shape. And make sure I cover all the same stuff that the rest of these parts A's, B's, and C's covered, or not A, B, and C, but the first parts to answer that last question. So I have the answer key that can either be shared with you or it might already be linked in Canvas, just depending on what's going on. So you can try these problems and then check that answer key. And then now we're going to move on to pause here and make sure you do all that. And then when you're ready, you can unpause the video at this point so I can go over the Chapter 7 practice test. So make sure you check the answer key to this FRQs, and then now we will go over this practice test. So if you haven't done that yet, that's your classwork for today. It's 10 informal points. Go into Sapling and try those 11 questions. Then come back here to debrief any that you had trouble with. I'm just going to go through each one. So like I said, just look at the top number here, and you can see which one I'm working on at the time and listen to my explanation for that. So for number 1, a study of voting shows 663 registered voters at random. Of those, 72% said they had voted in the election. So that's P hat equals 0.72. Election records show that only 56% of registered voters voted. That's P. Election records would be all results. This a study, so at random, that would be a sample. And so when they ask which statement is true, that makes 72% a statistic. Remember, they have the same letter. 56% a parameter because it's all possible. It comes from a population. So it was that one. Statistic, I'll just write this little note for you. That comes from a sample. Parameter comes from a population. And you're looking for words like true, actual, etc. All possible. Things like that. Okay, number 2. The Gallup poll wants to increase the size of its sample from 15 to 4,000. What will this increase do? So increasing the sample size decreases the variability, and that's all it does. So it doesn't reduce the bias, it's decrease the variability. It does not reduce the bias. It doesn't do anything to the bias. So bias is when you have a problem with your sampling method. So if I just sample more people but poorly, then I still get more, I'll just have more bias. So it doesn't affect the bias, only the variability. Remember, the formulas for variability are right here. This whole column. And all of them have sample sizes in the denominator. And so they are affected by sample size only for that. Number 3, suppose we select an SRS of 100. Let P hat be the proportion of successes in the sample, which is normal. We've talked about this already today. We have approximately normal when n times P is at least 10, and n times 1 minus P is at least 10. So with 100, like, that's pretty easy to figure out. That's the 85% one. So here, these are too small. N times P would be 9. But here, N times P would be 999, but N times 1 minus P would only be 1. Because that is also a rule. This one would be 85 and 15, so that's easy to see, and that's correct. Here we have 1 again. That's easy to see. Here, that would be 2.25 when you do N times 1 minus P. And so only 85 and 15. All right, number 4, central limit theorem. So the central limit theorem says that your sampling, I'll just put that in red, so it's like a note. Sampling distribution is approximately normal when your sample size is at least 30, no matter what the population looks like. And so in that case, it doesn't matter what the population distribution is. So I'm crossing off all 3 of these. It's not the population size, this is your sample size, so that's why it's that last one. Okay, number 5. This one's kind of tricky. So we have 2,000 from Johns Hopkins and 60,000 from Ohio State in the population. So they take a sample of 3%, which 3% of 2,000 is, I think, 60. So we have N from Johns Hopkins equal to 60, and then the sample size from Ohio State is going to be 3% of 60,000. 1, 2, 3, 4 zeros. That's 1,800. So the sample size is a lot larger for Ohio State than for Johns Hopkins. And so, but the P's are the same for both, the true value. And so Johns Hopkins will have less variability than, Ohio State will have less variability than Johns Hopkins. So that means it'll be closer to the truth just because there's less variability involved. But not because it's a larger population, because it will have a larger sample size. So the population size doesn't matter, it's the sample size. Now these sample sizes were calculated based on the population size, but they could have said, we sampled 200 from each, and the answer would be that they're the same distance from the truth because they have the same sample size. It's not population that matters there. Number 6, a researcher, blah, blah, blah. What size should the researchers use to have half as big? So this, we talked about this already once in this video. So if I want my, basically I'll show you this a little more in depth here. This is my formula. And so that I want it to be half the size. And so what you can do is think about, that would mean making my N 4 times larger, because if you think about this, I can square the top and square the bottom separately. So that means I'm like square rooting the 4 and putting it on the bottom. And then that's where they equal each other. You can also guess and check with your calculator and just try different sample sizes. What you could do on this problem is, let me see if I can find that calculator. So we have 160, we just can use 0.5. So we have square root, we'll just use 0.5 since we don't know what the P is. Or whatever. Oh, this is from a X bar. Oh my. It's even easier to see, but it works the same. So let me just erase what I was writing. X bar is going to be sigma over square root n. This one's even easier to see. So if I do sigma over square root 4n, then that becomes sigma over 2 square root n, and so I can rewrite that as 1/2, like that. And so you can see that 4 times the size here is the answer. Now, I just know that because I've done this so many times. Like I said, with the calculator, we could try it out. Just make up a sigma like 5 over the square root of 160. And then we'll do 5 over the square root. We'll just check that first one, 640, and I get that times that by 2. You can see they're the same, but half. Now, I would never choose that one or that one, so really can narrow it down that way, and then there is enough information. So. All right, number 7. We have blah, 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 n is 250. And then it says, all in all, 150 out of 250 are in favor. So that's your p hat from the sample. That equals 0.6. And it says, suppose that unknown to you, 55% of all undergraduates, that's a p. And so if you took a very large sample of SRSs, what would the sampling distribution be? Remember, the formula is mu of p hat equals p. So I would just cross off that, and then if we have 250 times p, 250 times 1 minus p, those are both at least 10. So then I would cross off those, never exactly. So I cross off the last one. This is the only one left. For that standard deviation, that's square root p 1 minus p over n. That's how you get 0.03. Number 8. Which of the following is incorrect? Okay, so if we read through each of these, the sampling distribution shows how the sample is distributed about the sample mean. That's incorrect, so that's the answer. I'll explain the rest. So the sample mean is an unbiased estimate of the population mean. That's always true because mu of x bar equals mu. That's the definition of unbiased. Standard deviation will decrease as the sample size increases. Remember, variability goes down as sample size goes up. We've talked about that so many times. This is the definition of standard deviation, so correct. And this last one is what the first one was supposed to say. So the sampling distribution shows how the sample mean is distributed around the population mean. So that's what it was supposed to say, and that's why the first one is incorrect. Okay, number 9. This one asks for the definition of an unbiased estimator. And so unbiased estimator says that mu of x bar will equal mu, and so that's this last one. It means that the population mean is equal to the mean of the sampling distribution. And so we don't know that it will equal, this was just a sample, not the sampling distribution. And so it won't always equal 810. And then the sample size doesn't make it closer, it's the method. So it's not that one either. And then, nope, unbiased doesn't have that to do with that in this case. And then it has to do with doing a random sample. And then it doesn't have to be normal. It's not part of the definition. Okay, 2 more. So this one's tricky. Suppose you're on a student aid in the library and agree to be paid according to the random pay system. The librarian will flip a coin. If it's heads, you get 80. If it's tails, you get 40. So if you work for the library for 100 weeks, suppose you choose an SRS of 2 weeks and calculate your average earnings. So for those 2 weeks, I could either get, so let's say I get 40 both times. There's a 25% chance of that. I could get 40 one week and 80 the next, or 80 one week and 40 the next for $60. There's a 50% chance of that. Or I could get 80 both weeks, just 0.25 as well, because it's heads times heads, tails times tails. And then this one is one or the other, which is where you get 0.5 from. Now, for me, I didn't do that to get this answer. That's just one way you could do it. And then if you looked at the distribution of that, that would be symmetric. You would have 40, 60, 80, a little symmetric distribution like that, but not normal because it's only 2 weeks and 2 is less than 30. And so not exactly normal yet. But other ways to think about it are, we don't know if it's right or left because it's flipping a coin And so that's not heavily weighted one direction or the other. So it could be, either way. And it's about normal because they don't say anything about normal. So I'll cross those off too. So that's why I would land on symmetric but not normal without having to do all this work that I did. Either way. Okay, last one. SRS, population of 0.8 successes, an independent SRS of size 400 is taken. So we have PA equals 0.8. The standard sample size for A is 100. PB is 0.5. The sample size for B is 400. So for the mean is just PA minus PB because it says A minus B. So 0.8 minus 0.5 equals 0.3, and that's right here. Standard deviation, we'll be using this formula right there. So that is square root 0.8 times 0.2 over 100 plus 0.5 times 0.5 over 400. And with that one, I think I got 0.0472. I have to remember. Let's see. 0472. And so that goes there. All right. So if you have any questions, make sure you attend tutoring and or come back into the asynchronous, whatever's going on. And then you can prepare for your test by watching AP Daily videos and looking back at all of the stuff we've done this unit so far. Thank you guys. Hope you have a great day. See you next time.